Question number 26. A light of frequency in a vacuum is normally incident on a diffraction grating that is containing number of lines per meter. Okay. What is the angle between the adjacent second and third order intensity maximum? Okay. Now, if something has to show in a diffraction grating, what is the equation that governs it? Equation that governs it is d sine theta is equal to n lambda. Okay. Now, is lambda given? No, you can find out the value of lambda from here. How? See, we know that lambda is equal to c divided by f, right? V by f is equal to lambda. So, we will substitute this 3 into 10 to the power of 8 divided by 6.7 into 10 to the power of 14, which should now be, let us calculate this. Where is it? Where is my calculator? It's here. It should be 3 divided by 6.7 is equal to 0.4476. 0.45 into 10 to the power of how much is it? 10 to the power, here it's 8, that side minus 14, this should be minus 6 meters over here, minus 6 meters over here. So this is what it should be, your wavelength. Okay, is it right? We are doing something wrong over here. See, 8 minus 14 should be minus 6, that's right. Okay, 4.5, I get this as 4.5 into 10 to the power of minus 7 meters I get, right? Which should be 450 nanometers, that's right. Okay, we should always look at this. Okay, otherwise we will get to know we may be doing incorrect things. Okay, lambda is got, and then what does it say? Adjacent second and third order maxima. So angle between them, we need to find sine theta 1, which should now be equal to n second order, it is 2 into lambda is same, divided by d. Oh, d is there, d we do not know. Okay, let me keep this as d, we will find out d also here. So what is d? D is equal to 1 by n, which should now be, what is n here? It's given here, 1 by 4 into 10 to the power of plus 5, okay, which should now be equal to 0.25 into 10 to the power of minus 5. Okay, this is the value of d. So I got the value of d also. Sine theta 1, I get this value, and then sine theta 2. Sine theta 2 is equal to what? This is third order, which should be 3 lambda divided by d. Okay, so what I will do is, let us find out the value for lambda by d also, which becomes easy for me. It is a bit intensive, calculation intensive problem. Lambda, we already got this, which should be 4.5 into 10 to the power of minus 7 divided by the value of d, we have got it here, 0.25 into 10 to the power of minus 5. When I do this, how much do I get? Let us calculate this one here, which should be 4.5 divided by 0.25. I get this as 18 into 10 to the power of minus 7, 10 power minus 5. When it goes upwards, it becomes 10 power minus 2. What is this now? This is nothing but lambda by d. Okay, we got the value of lambda by d, which is equal to 0.18. Now, what do we have? Sine theta 1. Sine theta 1 is equal to what? 2 lambda by t, which means what? It should be 0.36. What is sine theta 2? Sine theta 2 should be 3 lambda by d. 3 lambda by d is nothing but multiply this one by 3, which should be 0.54. Then what is theta 1? Theta 1 I need, let me take my calculator. It's not so easy to find it out manually. So what you do is, close this 0.36, go to trigonometry, type to second, put sine inverse, I get 21.1 degree. 21.1 degree, and theta 2 in a similar way, 0.54, and go to trigonometry, second and sine inverse, I get 32.68. 32.6 over here. When I subtract this 2, what do I get? 6 minus 1, 21, 6 minus 1 is 5, 2 minus 1 is 1, 11.5 degree, which is nearby 11.5 degrees, 12 degrees. Answer is here. Okay, this is a lengthy problem, but nevertheless, you need to do with calculation. There is no other easier method to calculate this.